My name is Serpil Bayraktar, for those of you who don't know me, and I'm the program lead for VET. I'm also a principal engineer in Chief Technology and Architecture Office here at Cisco. I hope you enjoyed the activity. Give us some feedback. I'll send out a survey at the end of the day today. Let me know what you think about it and if you have any other suggestions. So today's topic is Facebook's news feed. Let's first of all show of hands who has a Facebook account. Okay, let's see who does not have a Facebook account. Okay, we have a few. That's all right. That's all right. So I have a Facebook account. I am what you call a power user. I share a lot. Maybe a little too much sometimes. But what's really nice about Facebook for me is that if you don't like what I'm posting, you can just move on to something else. You know, you don't need to be annoyed. You don't need to tell me what to post and what not to post. Just move along. Sometimes people say, but your posts show up on my news feed. And maybe that's because you like me a lot. I mean, literally, if you keep pressing the like button, the chances are you'll see my posts on your newsfeed. Which brings me to today's topic, which is the newsfeed and how Facebook decides what goes on to individual news feeds out of billions of posts. And that's what Uzma is going to talk about. And Uzma is a product manager at Facebook. She's leading the feed recommendation team. And she has a very interesting background as an engineer, product manager, entrepreneur. So she'll talk a little bit about herself. But I also just heard that she had a baby 2 weeks ago. So please all welcome. Join me congratulating her. That's wonderful. And I want to thank Uzma for coming here, especially considering that she had a life-changing event and drove all the way here. I'm a big believer in the diversity, not just in gender diversity, but culture, point of view, company. So it's really nice when we get an external speaker here at Women in Technology. So please help me welcoming Uzma to our community. Thank you.
Thanks so much, Serpil. It's my pleasure to be here. It's quite a big turnout. I'm really excited to talk about, how newsfeed is impacted by machine learning and give you a little bit of insight into how we make it, relevant for you. Also, if you have any questions on the product itself, my background, career in technology, I'll be happy to take it at the end. We'll leave about 10 minutes at the end for Q&A. All right, so we'll get started. So looks like all of you have a Facebook account, and we need to get the two people who don't to open an account. I'll get started on my background a little bit. Let's see. Oops. Okay, 1 second.
Does that work? Let me see. I always have a technical difficulty.
Yeah. No matter where the world is, you'll always have IT difficulties.
There you go.
Cool. So that's me. So we launched a product called Facebook Live. That's with Zuck kind of coming into a room at that time. So I'm a product manager. I work on the newsfeed product. I specifically work on feed recommendations, which is basically allowing you to discover new products across Facebook, but through your newsfeed. You might have seen things like people you may like or pages you may like, things like that on your newsfeed. So I work on a bunch of those products. Before this, I started my own company in the machine learning space. What we were trying to do is apply machine learning and help SaaS companies prevent churn. And before that, I was at Stanford. I finished my MBA, and I was an engineer turned product manager. So if you have any questions about career and transitioning, I'm happy to take it at the end. All right, moving on. Oops. So I'll start with what is Facebook's mission, because that really shapes how newsfeed turns out for you, because newsfeed is one of the biggest products on Facebook that people spend time on. So Facebook's mission is to give people the power to share. and make the world more open and connected. People use Facebook to stay connected with their friends and family, to discover what's going on in the world, and to share and express what matters to them. So these are the values that Facebook exemplifies, and Newsfeed is the biggest surface through which we share these values with the world. So the goal of Newsfeed is to show you the most relevant and meaningful stories. Every day we have billions of stories. We have 1.9 billion users who log into Facebook every month. And each of these users, post and share photos, videos, links, articles, their own thoughts. So we have a ton of stories that we could show to each individual user. So it's a big challenge for us, because the thing is, every person has only limited time. You don't have hours and hours of time in the day to go through every story that your friends post. So we want to show you the stories that matter most to you, that are most meaningful to you. So that means sorting through billions and billions of stories and showing you the ones that you're most likely to be finding meaningful. So that's a big task. So the way we do it is we also have the newsfeed values, which are basically a derivative of the Facebook mission itself. And those influence how our algorithms pick what's most important for you. So the newsfeed values that we shared last year was that friends and family come first. Facebook, as we talked about, the mission, it's basically connecting you with your friends and family. So newsfeed also embodies that. And we want to be a platform for all ideas, which means that we are not trying to be kingmakers, but we're really trying to connect you and with other content that you may be interested in. So we are a platform, and we are not a content machine. So which means that people produce content, we don't produce content, but we just connect you to the content that's most interesting for you. We also care about authentic stories. So what that means is, there are publishers or pages which may be doing things like clickbait, etc., which means they're just trying to make you click on things, and those are not authentic stories. So we care about authentic stories because that's what matters to people, is what people tell us. So that's again another value for Newsfeed. And the fourth value is that we let you control your experience. What that means is we allow you to hide pages. If you don't like something, you can unfollow your friend, you can unfollow a page, and we use those signals very strictly so that we don't show you what you don't like. And the fifth thing is we always keep iterating. So we're always learning, we're always talking to our users and iterating that experience so that it can always be the most relevant. And the Facebook newsfeed of the first version that started out, today the version that is there, it's very different. And we're always learning and improving and iterating as the needs of our users change. So I'll share a little bit about the elements that go into the newsfeed ranking algorithm. So there are four big buckets. So one is the inventory. So these are all the stories that have been posted by your friends and the pages you follow. So this is like the whole inventory of stories that we could potentially show you. These could number from hundreds to thousands depending on how many friends you have and how many pages you follow. So it can be a lot. Then what we do is we use signals. So signals, there are like thousands of signals. I just shared one over here, like who posted the story. For example, if it's somebody who's really close to you, somebody you care about, we use that signal to decide which of these stories from this inventory of stories we pick for you. Then we have predictions. So predictions are basically kind of machine learning algorithms that are trying to understand how likely are you to engage with the story, how likely are you to comment on it, spend time on it, like it, share it, so that we know we can kind of understand that, okay, this is likely to be important for you. And all of this gets combined into a relevancy score, and I'll show you in a little bit what that is. So whenever somebody posts a story, so there are a bunch of elements that go into it. So one is who posted it, then the content that is shared, then you have people who engage with it. So these are all the signals. I've listed them out very simplistically, but these have like hundreds and thousands of variants and multiple different ways that we look into it over time, not just at this story, but also stories that you have, people have shared and you've engaged with over the course of your time on Facebook. And then we use your interactions with this story as well as other stories to understand how much time are you likely to spend on it? Are you likely to comment on it? Is this content actually informative for you? is this likely to be clickbait or a low quality post which may have like nudity, etc., which people don't like? So we have like machine learning algorithms that actually try to predict these things. And what we do is we take all these predictions and then translate it into a score. This is the score that I put in the top. It's like an example score of like 2.7. So what we do is all the stories that we could potentially show you, we rank these. We assign scores based on all these predictions that we run, and then we rank this into your newsfeed. So we have all these stories, each gets scored, and ultimately what you see in your newsfeed is basically the top stories that have the highest scores of relevancy. Any questions? We can take it in the end. Yeah. So the question is, why are we using machine learning to rank these stories? Why not use something simple saying that, okay, this is my friend, I interact with her post, always show her story at the beginning. Or this is, a page I interact with, I always like this post, always show this post at the beginning. So the reason is scale. We have 1.9 billion users, and any simple heuristics are not going to scale to all these users. So what machine learning allows us is to personalize this experience for each individual user. People use Facebook in very different ways. Though we've shared the values that we have in the beginning, which is like friends and family matter most, and then it's a platform for ideas, but there are always people who use it very differently. There are people who don't interact with friends and family at all, who follow a lot of different pages and then use Facebook basically as an information platform. And there are people who actually don't want any news at all, and all they want to see is content from their friends and family. So what machine learning allows us is that build a more personalized news feed for each user based on the signals that you provide to us. The other challenge with the Facebook scale is that each time a person posts something, it's very different. People post videos and articles and photos. Knowing what the content is also very important, because yes, I shared a photo of a baby and you liked it, but did you like it because I shared it or because it was a photo of a baby? Because if it was a photo of a baby, maybe I could show you more baby photos. So it's very important. So maybe it's very important for us to understand the content that's there in the content that people share. And that's a very complex problem because we have 1.9 billion users who are sharing content from all over the world. And knowing what is in these images and videos is very important. So that's where machine learning helps. So I have two images here. One is like a man riding, wave on a surfboard in the water, and the other is, a man riding a motorcycle. And those are very different interests. If I were to show you one where you're a surfing enthusiast, but I show you, photos of like bikers, you're not going to be interested in that. So for us, it's really important to understand like what is it that you find engaging, and which is why machine learning is important to understand what goes into these images. And the third piece is language complexity. Again, we have users from all over the world who converse in all these different languages. For us to understand and also allow people to connect, we have people who connect across boundaries, across geographies, and machine learning helps us basically connect users by allowing us to translate. So when my friend shares something in Spanish, Facebook allows me to kind of translate that and understand what she's speaking. So yes, in the real world, it might be much more difficult for me to converse with her, but on Facebook, I'm able to connect with her much better because machine learning helps us translate. So there are these key capabilities that machine learning enables us, and these are essentially like taught. What we want is basically ability to predict. Humans are very good at this. So this is like screenshot of a game called Go. So when you're playing a game, we understand or we can predict, okay, this is the next step my opponent is going to make. And we want machines to also be able to predict what is it that you're going to like next, or what is it that you're going to engage with or find meaningful next. So, and we cannot have humans do it, so we need to enable machines to do it. So we are teaching machines the ability to predict better. The second capability that we are investing in is sight. As I shared earlier, we have different kinds of images. These are like few screenshots. So one of them has like animals, one of them is from a bakery. It's important for us to understand what goes into these images so that we can show you more relevant content. And that's what we are investing in computer vision. And The other element is speech, as I said earlier. So we need to understand what people are talking about. So yes, if we have a French speaker, how can I better understand and translate whatever he or she is speaking into, say, for an English speaker? So that requires us to translate, languages and build language models and understand natural language processing. So those are the investments that we make in terms of our machine learning background. The challenges of working on machine learning are many, though. We have hundreds of engineers who work on all these different pieces of the machine learning platform. And the challenges are that they're running thousands of experiments. We have engineers with varying level of expertise with machine learning. There are people who have just graduated from college. There are people with PhDs who have tons of experience. But we want to enable everyone to be able to contribute to this, to the various products that rely on machine learning. We also have people that are working on what's called feature engineering, which is basically ability to predict, but deciding what factors go into those predictions. So that is one of the key elements of machine learning models, versus deciding what algorithms to pick. So these are two different capabilities. Feature engineering is more important for getting accurate predictions. Algorithms requires a lot more deeper expertise. Many algorithms are reusable, so you have so many engineers, they might be working on the same thing. So how do we prevent duplication of effort? We also want to improve speed of execution. So one thing that Facebook really lives by is its hacker culture, which means that we want to, if you have an idea, take it, prototype it, build it, and ship it. So to enable the hacker culture, even in the machine learning environment, we need to ensure that speed of execution remains high. And then our ability to scale. We have 1.9 billion users. Imagine the amount of data that we produce daily. So enabling all these engineers to also work on the data at the scale and still be fast is a big challenge. So because of all these challenges, Facebook worked on building a platform called FB Learner Flow. This is basically Facebook's machine learning platform. As you can see over here, video, photos, search, newsfeed, speech, and accessibility all kind of rely on this platform for driving their machine learning products. So the benefits of Facebook Learner Flow is that each machine learning algorithm is implemented once in a reusable manner, which means that if you're an engineer, you can always search and find something else that some other engineer has built, and you don't have to reinvent the wheel. Training pipelines. So for machine learning algorithms, it's very important that you have data where you train your models on. And what this allows is that we have lots of machines, and the training pipeline can be distributed over all these machines and also can be reused by many engineers. Training a model is very easy for engineers of varying expertise. So which means that, even as I said, fresh grads can also get started really quickly on this platform without having to, spend years and years of experience learning the system. And then you can also search past experiments, view results, share with others, collaborate and start new variants. So it really amplifies and speeds up the learning cycle for the engineers. So I'll share a little bit on the technical details of this platform. So we have what is called like an operator. So if you're an engineer, you'd kind of, the closest analogy would be like a function within a program. So this is like the bare minimum executable that's executed on a separate machine. And then we also allow like arbitrary binary packages, which allows us to also use external libraries. And we have like type checking on this. So after we have like the basic units that kind of execute on a machine, we have what is called a workflow. Our workflow basically kind of puts together all these different operators into a cohesive manner. So over here, there's a bit of code over there. So basically what it does is that it takes all these operators and kind of puts together the workflow that you want. So for example, if you have a machine learning pipeline where you need to split the sentences into smaller words and then use those words in a neural network. So that's where you set up the workflow for this. And then as I shared earlier, like data is a big challenge. Imagine we have like 1.9 billion users who are generating trillions of data points every day. So if you're building any program, if you're an engineer, you'll know that copying data from one machine to the other is extremely expensive. So what this does is it abstracts the data so that the engineer doesn't have to worry about it, and they can just give the instruction to the machine and say that, hey, I want this to be run this way, and the channels basically, which kind of takes care of where is the data and where should this program be run so that it's closest to the data. So this really fastens up the process of running all these machine learning models and code, and you don't have to worry about copying like billions of data points from one machine to the other. So all of that is abstracted away. So it really makes it much, much faster for engineers to run machine learning pipelines. The algorithms that supported, I'm not sure how many of you are like conversant with some of these algorithms, but essentially we support like neural networks, gradient boosted decision trees, lambda mart, stochastic gradient descent, and logistic regression. So these are some of the algorithms that are supported, and we're always also working on supporting new algorithms in this platform. So that's kind of it in terms of my kind of introduction to the Facebook machine learning platform. So we have actually quite some time to answer questions. So I'm happy to take questions now if people have.
About a month ago, Google released their. This is more on the hardware side. I'm not sure if you're working on with Jan LeCun's team or not, but it's a question on the compute infrastructure that's underneath all these algorithms. Seems like the easy way to do this and the quick way to do this is on GPUs right now, but Google's making a very strong case that their Tensor processor, their ASIC, would be a much better, cheaper solution to do this. First of all, how are you guys running these algorithms on what type of compute infrastructure? Number two, how does your view of the Tensor processor, and can you run with can you scale with what you have with like GPUs that are really expensive and really power hungry? Thanks.
Yeah, so I'm not familiar with the compute, the whole stack, but I'll share what I know. So yes, we do use GPUs inside of our stack as well. Like Facebook basically has built its own stack, like using the Open Compute framework. In terms of like Google's TensorFlow, I think the more, I'm not sure what algorithms it supports, but for doing like deep learning as well as for like deeper neural networks, I do think that GPUs are necessary. So I'm not sure, like I haven't looked at their kind of compute hardware or like their compute stack as well. But we do use GPUs on Facebook, yeah.
No plan to go on your own and build your own ASIC?
Not that I'm aware of, though I should always say that I'm not that familiar with the hardware stack, yeah.
Hi. So what kind of analysis you do prior to pick up the use case that machine learning will actually benefit? So I wanted to know, like, how do you pick the use case for that, machine learning will actually benefit the organization or give you the relevant data, or, so what is the analysis you do before picking up the use cases?
Yeah, so it depends a lot. I mean, right now, basically, one of the biggest drivers of machine learning is basically the scale challenge. Like any problem at Facebook scale, it's like it's so hard to do it at any other way. That machine learning is definitely kind of a fallback option, which is chosen by teams across the board. But in general, I'll share like, kind of the best practices of when machine learning is a good option and when it is not, when you're working at a different scale. At Facebook scale, it's kind of an obvious option at this point. But essentially, the first aspect is that, do you even have data to do machine learning? A lot of companies out there, a lot of startups, they all talk about AI and machine learning, but they don't have data. The thing is, if you don't have data, you're not going to be able to predict anything. So the first step is, do you have enough data where you can actually see patterns, where a machine could recognize those patterns and actually give you good predictions? So that's the first step. The second thing is, I would say like complexity. If you have a problem that has a simple solution, you shouldn't over-engineer it. So machine learning is not a solution for that. It's when the problem could be interpreted in different ways by different people. What that means is, I might have a different experience of that problem, and somebody else might have a different experience of that problem where it needs to be personalized to each user. So that's when machine learning really shines, in the sense that it's able to personalize it to me. Whereas if you have simple heuristics, a lot of the credit card applications, for example, have simple heuristics, right? So if age less than this and so on less than that, I'm going to give you a credit card. But the thing is, I might be of age, less than 50, but my, risk profile might be very different. So I don't slot into those buckets very well. And machine learning is able to kind of, give a much better results in those situations instead of using like simple rule-based heuristics. Yep.
Hey, thanks so much for coming. So I have two questions, but it's related. So I think the first one is that in the machine learning algorithm, do you ever think that inject random content? For example, you say you want to see babies and then you keep seeing more babies, but sometimes I'm not explore my interest. So if you inject, like random content, maybe I like it. And the second question is related because do you ever think of remove the bias in the informations? So for me, I use Facebook to get up to the news and what my friends are doing. So I remember that during the elections, so I'm not supporting one way or another way, but I'm keep seeing my friends supporting Hillary. And I think that because I like in one of the posts, and that's why I have the bias that, hey, most of my friends are supporting Hillary's, and I have 2,000 friends on Facebook. But actually it's not true because the news itself is filtered. So I only see Hillary posts. So that is the two questions. Thanks.
Yep. So, so there are frameworks that kind of introduce randomness into, machine learning applications. So we do experiment with that in various ways. So, a simple one is what's called explore exploit. So what that means is basically we don't know for example, you might be interested in yoga, but you've never seen a yoga post on your newsfeed, or you've never liked a page that, shows yoga content. So how would we know that you actually like yoga? So yes, there are some algorithms through which we can actually show you some random content and then see, over time, like, is there some, maybe a post about yoga, maybe a post about, CrossFit, and then see what you like, and then, learn from there. So there are applications, I wouldn't say newsfeed does that, but there are applications that we are building which do, use that framework. In terms of your second question around bias, so we are working, on basically giving users a much broader perspective. So a lot of the biases are also built by users themselves, in the sense that, the kind of people you follow, the kind of friends you have, it is a little bit of a bubble. I mean, even for me, it's like when I look at all my friends, most of them are liberal, for example. But having said that, we are kind of taking this seriously. So for example, very recently in France for the elections, we launched a pivot. Basically, whenever somebody shares a political viewpoint, we also show what other politicians are talking about on that viewpoint. So we are working on a few different products in this area, and you'll hear more of it in the coming days. Yeah.
Hi, in the pictures you showed, like how you kind of scan them and figure out what they have. How do you do that for audio and video? Do you your algorithms listen to the whole thing and like see each and every frame in the video to figure out what the content is, or is there like a better way to do it?
Yeah, for video, it's all done like frame by frame. So every video is basically a collection of images, really. So we take each frame and then do the same process for that. Yeah.
Hi, we have a question from the bridge. How is Facebook detecting fake news stories?
So We recently, actually not recently, but actually a couple of months back in December, we launched a product by tying up with a few different news organizations, which are like fact-checking organizations. So basically, they do the fact-checking, and if they report it to us, then if somebody shares it, we mark it as disputed. So basically, it's a partnership between us and a variety of fact-checkers. Yeah.
Hi, thanks for your presentation. It was very interesting. I have a Facebook page for my music, and it reminds me every couple of days that I could be paying money to boost my posts. How do you take that into consideration with machine learning algorithms? Or how would you, decide which boosted posts to show to which people, or to which people you don't show it?
Yeah, so I work in the newsfeed team, though ads is a separate organization. But having said that, it kind of uses the same principles in the sense that we care about people engaging with that content. We have a saying inside of Facebook, ads as good as organic, which means that we want to show you ads that you find valuable. We don't want to blast you with content or ads that's irrelevant for you. So even in the case of boosted posts, we show it to users who are most likely to engage with that post, who have shown preference for content like that. So that's what drives kind of like what gets picked. Yeah.
Yeah, hi. Thanks for the presentation. It was very informative. So I have a question related to the model you have. So you have training data and then you have the model. So what is the accuracy of the model, and how many times, or what is the percentage of false positives, false negatives, or is it overfitting the model? Because your training data is with you, but all the 1.9 billion users are using that. So they are the real users of that model which you are using for ML. The reason I'm asking is because last year what I did is I randomly clicked on names of people with a test account to see that when it suggests me a new friend, it is not in the hierarchy of the friends or the connections I have, but the name started coming randomly. So is that a kind of a case of a false positive? I wanted to understand related to the model.
Yeah, so unfortunately, I cannot share like the false positive or the accuracy rates because those are all proprietary information. But having said that, like overfitting is not something you'd want with any model, right? If you're building any models, I don't know how many people are familiar with overfitting and underfitting, but just kind of I'll share what that is. But if you train a model on a particular set of data, if the data fits your model extremely well, so that's basically kind of an example of overfitting, because it might be that you have new data coming in, and the model does really well on your training set, but doesn't do that well when it's actually deployed in production. So and you don't want your data to be your model to either overfit or underfit. You just want it to be calibrated just at that right level so that the prediction accuracy is at a decent level. So I mean, we definitely don't want our models to overfit, and we test that. And any experiment we run, we have metrics that we calibrate it against. So yeah, that's yeah.
Hi. So I wanted to ask you about data privacy, because you were showing some images and how it detects and create models with voice, video, and images. Just wanted to know how the user is protected from the privacy. Yeah. In general.
Can you elaborate? What do you mean, as in like data privacy of like?
Yeah, for example, if I post something and then a friend of mine likes it,
Mm-hmm.
I have in my mind that the data will be taken by the machine, and how is my privacy protected?
From like being shared with your friend, or you mean from like the engineers, or?
Yeah, from Facebook.
Oh, I see. Yeah. So, I mean, we have basically kind of, very strict rules. We cannot access user data. So all of it is like kind of anonymized. And so we cannot tell which user it is. We just know it in aggregate, if that makes sense. So we don't have access to user data at all. It's not like I can go and look up all my family's data. Yeah, so I can't do that. So I'll be fired if I do that. Yeah.
Hi, I just have a question because I know Facebook has research and does a lot of research, including some research with kind of how people react when they see things on like their news feed, and if the saying sad things makes them sad or happy things makes them happy. I was kind of wondering, how does that play into what you show on news feed?
So is your question that do we take into account emotions when we show you things, or?
Well, I guess I'm just kind of wondering, like, how does is there a way that like what you show kind of like partners like with the research sometimes when they're like experimenting, or is that kind of separate from how you just decide what to display to your user?
I'll just rephrase. I'm not sure I understood it correctly. So do you mean that when there are research experiments going on versus what we actually ship? Is that the question, or?
Yeah, it's like I guess I'm just wondering, like, does it change when like there are people doing research? Does that change what they actually show in your news feed versus your machine learning algorithms?
Yeah, so there are always, data scientists and research scientists who are always experimenting and trying to understand what, people value. So if they have something that, we find that might be valuable to our users really enjoy, that new version of the experiment, we'll ship it, after taking into account all the different, effects of that. So that's kind of part and parcel of how we run things. In a sense, we're always trying to experiment and learn more. And then if we know that, a certain experiment is doing much better, so that's something that we'll ship to our users.
Hi, so I'm on Facebook, but I only accept like friend requests or send friend requests. I don't post anything, I don't like anything, I don't follow anything. So I'm curious what shows up on my news feed, how is that determined with machine learning if I'm not giving any inputs for that learning?
Do you not like your friends' posts
No.
or comment?
I literally just accept and like send friend requests just to have the connection.
Do you click on things? Do you click on your friends' photos?
Maybe photos. I mean, I
Okay.
can't remember a time that I have, but I can't say no.
Okay.
Necessarily.
Yeah, I mean, we use a variety of signals. It's not just like comments. If you're logging into your account and you spend time on your news feed, we look at how much time you're spending on each story. And if you occasionally click on a photo or something, that's definitely also taken into account. Yeah.
Here's a question here. Thanks for the presentation. I know Google share a lot of their machine learning infrastructure and algorithm data model to contribute to the open source community. And I'm sure Facebook has a lot of good algorithms, and you mentioned it shared amongst the Facebook different business unit. So is Facebook just keep those algorithms proprietary to inside the Facebook, or is there any plan to contribute to the open source community?
Yeah, that's a good question. I think so far it's all like closed source at this point. But having said that, I mean, we are always, open sourcing different parts of our code base all the time. So if the time is right and we think, this is the major challenge is that the code base that we actually share with the open source community has to be actually, something that people could use, and it's not proprietary or not tied down to our infrastructure stack. So all of those things need to be taken into account when we do open source it. Facebook has shown, an interest in doing this in the past. We have like a bunch of different frameworks in our general code base that are open source. So this also might be something that we might do over time. But as of now, it's not.
Hi, I've noticed lately that Facebook's almost a little bit too good, almost kind of like Big Brother. Like I'm searching for a dress for a wedding on my phone, and then I go on and the same dress I just searched for is like popping up on my feed. A little creepy. So I wanted to know why and how, and just questions surrounding how you use your algorithms to do things like that.
So is this like something you've searched elsewhere and then it shows up on Facebook?
Yeah, like I'm on the internet on my phone.
I see.
And then I go on Facebook on my computer, and the same dress I just searched on my phone is now like on my Facebook feed.
I see.
So it's even not on the same medium. So I'm like, wait, okay, I was just on my phone, now I'm on my computer.
Yeah.
So I've noticed those things, and I just want to know if you could provide us some insight into how that's taken into account.
Yeah, so that's a pretty standard framework used by a lot of different companies. It's called retargeting. You might have seen it even on other sites, like, they follow you around in some sense. So advertisers, basically what they do is, if you search for something on their, about the product, and they're able to kind of find and link you to a account, it could be either Google or Facebook or whatever. What they'll do is, hey, I know she spends time on this. I'm going to just send this ad back to her on this site. And they do it across the web, not just on Facebook. And people notice it most on Facebook for some reason. But, you might be on a different site and you'll find that ad following you everywhere. So that's pretty standard, like, advertising technique. It's called retargeting.
Hi, I'm here. Thank you for your presentation. I think it was very informative and provide us insight into how Facebook is, generating the news feed for us. So I have a Facebook account, and similar to her, I don't post anything since I joined information security 4 years ago. So yeah, I don't like anything. I don't post. So I just don't. But I do go through my news feed. I don't know how is it generated, but it is very relevant to my interests or my family that I see. So that was one that's good. The second question was very similar to her, that in my news feed I see randomized content and wherever I go, but you provided that answer. You just said that it is retarget kind of marketing, and it is everywhere. Even if I go to the Google search, I see similar ads, whatever I have searched for. But my third question is, I follow one group, and that person lost his daughter, that he is very sad, and he posts some very sadistic comments. So Facebook came back and said that, if you need help, dial this number, so and so. So my question is, is this a new product, or is this a new something, machine learning, that Facebook is trying to do something, that if you post some comments and if it finds that they might be suicidal, or you are depressed, mentally depressed, and they are doing something in that area?
Yeah, so there are a ton of products, by the way. I mean, Facebook is a 10,000 people company, so I don't know if everything that's being built in the company. But having said that, Zuck recently shared about, like, what we want to be as a company and as a product is, support the community around us, support the community on Facebook, which means also supporting people who are, who could be suicidal, who are, in situations that are not, very, kind of conducive to their mental health. So we are working on a variety of initiatives to help users on that front. And on a variety, and not just on this angle, but also helping users connect to their, political representatives, to, build better communities. So there's a bunch of, like, initiatives definitely being worked upon. I don't exactly know the specific feature you're referring to, but yeah, so we are definitely investing. It could be, as in, like, machine learning is, as I said, like, there are hundreds and hundreds of engineers working on it. So I'm guessing that there is some machine learning component to that, in the sense maybe some phrases that are being identified, and then, it automatically suggests that this could be related to something where you need a helpline or something. Yeah.
Hi. First of all, congratulations on your baby.
Thank you.
And I think it's amazing that you're here only 2 weeks after
Thanks.
Delivering your baby. I have a question about, you said that your engineers run experiments on users. So how are those users chosen? Is it like an opt-in thing, or is it you randomize the choice in the users that you're experimenting on?
Yeah, we have a framework where we kind of randomize the users. So it's basically, each engineer kind of decides, like, how many data points they want. And based on that, basically, we have, like, out of all the users that log onto Facebook, we select a random sample of that. Yeah.
Question over here. Same side. I noticed in the news feed, when you get some content that you're not interested in, there's a pull down, you can say, don't show me this type of content.
Right.
And for the casual Facebook user, it didn't seem like a real obvious way to change your preference. I was wondering if you do any work on making it easier for the user to control the content that they're getting on their news feed, or when they post something, controlling what can be shown on their friend network.
Yeah. So we do have a few products where we've made it much more obvious to users that they could change and sort through their newsfeed or change who they follow and so on. What we've observed is most people don't use those controls as much. Most people actually just want to go through newsfeed, don't want to spend a lot of effort kind of changing their default preferences. And that's also one of the reasons why, so another sister product for Facebook is like Instagram. And Instagram recently moved from a chronological feed to a ranked feed. And primarily one of the reasons was that there's so much content. People don't have enough time to actually go and sort through everything. So allowing ranking to kind of choose what, and based on your behavior and your past actions, it tends to give a much more optimized experience. Having said that, we do expose a lot of controls. As you noticed, in the drop down, you can kind of, unfollow things or hide a story. We also have something called See First, which is that you can actually pick, users or your friends who you want to always see content from. But very few users use those controls.
Over here, a question. Same side again.
Oh, yeah.
Thank you for your presentation. So lately in the news, there are stories about people using live stream to pretty much document crimes, right, in real time. And then those stories are posted on people's feeds for an extended amount of time. So I guess a two-part question. First is, what is Facebook doing to shorten the amount of time to mark a post or a live stream as explicit? And two, is there an ethical guideline even implemented in the algorithm that Facebook follows to either mark post as explicit or even to bring down posts altogether?
Yeah, so live streams are really hard because, so I personally worked on the Facebook Live product, and they're really hard because they're real time. And then even for algorithms, you need some time for them to process the data and then spit out a result. Whereas by that time, that stream has been watched by many people, shared many times over, and so on. So we really rely on the community to actually flag those. And once that gets flagged, we have, a team of people who actually look at those flag reports, and then based on the sensitivity of the video, they pull it down, and then we have some guidelines based on that. Having said that, we are investing in a bunch of technologies to catch these sooner, but I mean machine learning is not a magic potion for everything, and it's a hard problem, so that's something that we are still working on. Yeah.
So I had a question. So one of the goals of any social media marketing campaign is to create content which would go viral.
Mm-hmm.
So what role does the machine learning algorithm play in, either helping or not helping those contents to go viral within the social media?
So virality is driven by basically, the biggest driver is really content, right? Because if it was the algorithm, then some people wouldn't have been better at it than others. You could say BuzzFeed content, for example, does really well, because they know what clicks with people. So I would say content is really the key over in terms of driving virality. It's does it tug at people's emotions? This is what I see. The content that gets viral is the one that generates emotional experiences, and people really like it and want to share it with their own networks. So I would say it's driven a lot by content. Having said that, I think what a platform like Facebook provides is distribution, right? It's very easy to share and keep sharing, and then the network effects keep growing. So that's where I would say the platform comes in handy in terms of the scale. We have so many users, and it kind of multiplies at each level you share. It just grows and grows. But I wouldn't say machine learning specifically has a role to play there.
share the content, for example, within my friends network, they are getting hundreds of such contents. So at what priority does my content come in? That will depend on the machine learning algorithm, and that in turn will dictate whether the content is going to go viral or not.
Right. Yeah, so I think so. It again depends on like what it's competing against. So if we have a story, for example, that is a viral story that could appear on your feed, and we have another story from your close friend, sharing a important life lesson or life update or something. So I would say it really depends on what you engage with. So it's not necessarily that the viral story is going to be ranked number one on your newsfeed. It depends on what you engage with, in general. So if your friend's story is what you find most valuable, and we've seen that might be ranked number one, and this viral story may come in like much later. So it really depends on what people find valuable. Having said that, a lot of people do find these stories, engaging, and that's why they kind of, watch it and view it. So those signals do go into that algorithm, but I would say it's driven a lot by each user's own consumption patterns.
We have a question from the
Hi.
bridge. Real quick, sorry. Are there plans being made in the machine learning design to expose Facebook users to new and challenging ideas in the form of suggested articles, etc., or insulate us in ideological bubbles? Example of having similar friends with liberal values.
Yeah, so as I had shared earlier, so we are working on a bunch of products in this, kind of domain. As I shared, like in the French elections, we launched a pivot which, for example, if you share an article from, say, Macron, and then, there are other politicians also talking about that same opinion. So we show you a pivot of like what else everybody else is talking about. So it gives you a wider perspective. So we are working on a bunch of products like that. And we'll have more details in the coming months. Yeah.
Hi, over here. So on the post, you can post emotions instead of just like, right? So I was wondering if there is an order to prioritize them. For example, if someone reacts as love, that's prioritized over anger. So is there some kind of order, or is it same priority for every emotion?
I mean, right now, not that I know of. Basically, all of these count as like, a way for you to express. And as I shared earlier, Facebook's mission is to help you express. So it's not like we want you to express only positive emotions. If it's to be an authentic platform, we want you to express like both positive and negative emotions. And that's the reason why we launched reactions. So our goal is not to rank one reaction higher than any other. Yeah.
Hi, Uzma. I have a question.
Yeah.
So for people who are interested in learning more about machine learning in general, but maybe specifically the area that Facebook is focusing, are there open source projects that they should be looking at? What would be your suggestions?
Yeah, you can go to research.facebook.com. So that has like a bunch of like content there. We post like articles about like all our recent like machine learning approaches and what we're doing. We don't have a ton of like open source products yet. There's one, we have like a few modules on top of like Torch, which is a platform. So people can go check that out. So that would be my recommendation as of now, at least on the machine learning side. On the general code base side, there's like, bunch of different frameworks that there's something called Flow that is open source, but that's not machine learning per se. That's JavaScript. And then there's React, which is also open source that people can check out. Yeah.
I have one other question quickly. Maybe this should have been asked at the beginning, but so what is machine learning?
Okay.
Because there's analysis. I'm running a project where we do a lot of network analysis, and now we're trying to do some machine learning on the networking data that we collect from the internet. And we come across this question where we think we're doing machine learning. Somebody comes along and says, that's analysis, that's not machine learning. So if you can describe that, I think that would be helpful.
Yeah. So machine learning is basically allowing machines to make decisions. It's how I interpret it, right? But having said that, a human kind of trains those machines. So the basic process is you take a large collection of data. There are patterns in it that you help that machine understand. And once that machine understands that patterns, when the next see a data point, they can do pattern matching on that and then, give you an answer based on it. So for example, we have like tons of photos of giraffes, for example. And then you start teaching the machine that, hey, this is what the giraffe looks like. And it's a hard problem because, giraffes can be short or tall, and they can be hidden by a bush, or they can be surrounded by a zebra. So the ability to know that, look at a photo and know that it's a giraffe, it comes very naturally to humans. But for a machine, you need a ton and ton of data points as well as sophisticated algorithms to go through every possible scenario. So you train the machines to kind of understand all the different scenarios. So the next time when we show that machine a photo, if it's trained well, then it'll be able to say that, hey, actually, I see a giraffe in this photo. And if we've done a good job, then even if it's, surrounded by a zebra or like, in kind of the sub-Saharan like bushes and so on, it still will be able to identify. So it's basically kind of teaching machines to think independently in some sense. Yeah.
Thank you. Any other questions?
One question from the bridge. It's, do you see an increase in fake Facebook names or accounts with users getting increasingly concerned with privacy?
That's not my area of expertise, so I wouldn't know the answer. We have a team that looks into this specifically, and they're always, so it's always like an adversarial challenge. Basically, any platform that does well, you'll always have like a rush of, spammers and, people creating fake accounts and all of those. So there's a team that specifically actually monitors that and always is like kind of on top of it in trying to curb it down. So I personally don't know the stats. Yeah.
Okay, so I have a question, and first of all, congratulations on your baby.
Thank you.
It shows your passion that you're here today, so thank you for that. I wanted to you mentioned about yourself a little bit in the beginning, like from engineering to product management. How did you move from one direction to the other, and what was your passion? What drove you to this machine learning? And can you talk about that?
Yeah. So I was an engineer. I was working at a hedge fund, actually. I worked there for about 3 years. So what drove me to product management was I wanted to be more on the creative side of building a product instead of like, building products to spec decided by others. And also I wanted to learn more about like kind of managing a business in general. So that kind of drove me to do an MBA. And during my MBA, I wanted to do product management because I still cared about technology and I didn't want to move away from it. So, and I really enjoyed that. And that's what kind of like kept me in that path. In terms of machine learning, what drove me to that? It's basically, I would say, I mean, in some sense, it's like where the world is moving towards. A lot of things are going to get kind of automated and things are becoming smarter. There's a ton of data like never before. So obviously machines can do much better thinking. So it's basically the future potential of that area. And then, I had some friends and colleagues that I was kind of brainstorming some ideas around. And that's where like the idea of my company started out from there. So that's what kind of like took me down this path.
Okay, I just want to thank you all for coming, and I want to thank Uzma for coming to present us.
Thank you so much.
Thank you.
Yeah.
And in closing, I'm going to send out a survey. Please do respond if you can. We tried 2 things that are kind of different than usual. One is the networking activity, and then the other one is a much longer question and answer instead of a longer presentation. So do let us know, and I'll send out the announcement for June soon. Thank you.
And I just wanted to, the reason I came here was really to inspire people to kind of, take up careers in technology and especially in machine learning. So I would really encourage you all to not think of it as like rocket science and really kind of explore, avenues to learn more about it and get more interested in it. Thank you.
Thank you.